Here's an addition problem. We're adding two fractions with unlike denominators. We have in fact looked at this addition problem in a much earlier lesson on the quadratic formula. The rules for adding algebraic fractions are the same as the rules for numerical fractions. We need to find a common denominator, express each fraction in equivalent form using the common denominator, and then add the numerators. Well, the common factor here is a. One of the denominators is 4a squared, the other is a, so the a goes into 4a squared. We just need to multiply it by 4a. So we'll multiply the entire fraction by 4a over 4a, because 4a over itself is 1. So we're multiplying in a way that expresses the fraction as an equivalent fraction with a different denominator. And there it is. And now our denominators match. So we can write a single denominator with the numerators on top. Since they're unlike terms, they can't be combined. They're also not factorable, although as you may remember from the quadratic formula, it's preferable to switch the order and write b squared minus 4ac over 4a squared. Well, here's a new problem, very similar, but now we've added a b to the first denominator. So now both denominators need to be changed because neither denominator goes into the other. Our common denominator is going to be 4a squared b. So the first one is multiplied by 4a over 4a, and the second fraction needs to be multiplied by b over b, so that both fractions will end up having a 4a squared b. And you can see our numerators after we've done the multiplications. And there's our simplified fraction, but if you like to write it in the other order, you may. Either one of those bottom two lines are fine with me as simplified fractions for the original addition problem shown at the top. Here's a brand new problem. The denominators are numerical. 4 goes into 8, so all we need to do is multiply the first fraction by 2 over 2 to get a common denominator. We apply the distributive property on the n plus 1 times the 2 to get 2n plus 2. Now we combine like terms. 2n plus n is 3n, and 2 minus 1 is 1. The common denominator is 8. Cannot be simplified any more than it is. So there it is, 3n plus 1 in our numerator, 8 in our denominator. Now we're going to take those same two fractions and subtract them. Well, the common denominator part is the same. Now we have to be very careful because we're subtracting the entire fraction n minus 1 over 8, which means when you're dealing with the numerators, we're subtracting the entire numerator n minus 1. Well, 2n minus n is n, but be careful, the 2 minus the minus 1 is of course the same as 2 take away negative 1, which is like adding 2 plus 1. So our new numerator is n plus 3 over our denominator, which is 8, and it's in lowest terms. Here's one with 3 numbers. The first 2 is subtraction, and then we're going to add a third one to the difference of the first 2. They have 3 different denominators, but since 3 and 7 go into 21, we won't have to change the third fraction, but we will have to change the first 2. Since 3 and 7 are relatively prime, we need to multiply the 3 by the 7 and the 7 by 3. And if you multiply a denominator by 7, you need to multiply the numerator by 7 as shown. Same in the second fraction when we multiply by 3 over 3. Gives us 7n over 21. Take away 3n over 21 plus n over 21. We combine those 3 numerators to get 5n over 21. It's in lowest terms, and we're done. Here's one also has 3 different denominators. The 9 and the 2 are relatively prime. 9 times 2 is 18. 6 goes into 18. So we'll multiply the 5n over 9 times 2 over 2, the 3n over 2 times 9 over 9, and the n over 6 times 3 over 3, giving us 10n over 18 minus 27n over 18 plus 3n over 18. We combine those 3 numerators. The denominator is going to be 18, and the numerators combine to be negative 14n. And this is the first one. We can simplify this fraction. Negative 14 over 21, of course, is negative 2/3. We still have the n, so our final fraction is negative 2n over 3. Here's one. The denominators all contain variables. One is an AB, one is a BC, and one is an AC. So, of course, I hope you figured out the common denominator is ABC. The first one multiplies by C over C, the middle one by A over A, and the last one by B over B. This is what we get. We write them all over the common denominator. None of those terms are like terms, so that's the best we can do. And there's our simplified fraction at the bottom. Here's one where the denominators are the same. So all we have to do is write the two numerators over the common denominator. Then we realize we can factor that denominator, and then we can mark out the two matching binomials. And here's a case we need to put the ones in. We don't want to just write blank over 4, or perhaps someone might make the mistake and write 0 over 4. But n minus 2 divided by another n minus 2 is 1, so I write the 1, and my final fraction is 1/4. Here's one where the denominators have nothing in common. They look a lot alike, n minus 8 and n plus 8, but in fact they're relatively prime. So just like we did with the 2 and the 9, and we had to multiply them together to get the common denominator, we need to do that here. And here's my work. And it's a little more complicated. The distributive property is applied. So on the first numerator, it's 4n plus 32. The second numerator, 4n minus 32. We realize that when we multiply those two factors together, they become a difference of squares, n squared minus 64. Don't forget to bring down the subtraction symbol. Now we have to be careful. The 4n minus the 4n, of course, is 0n, but the 32 take away another minus 32 is the same as 32 plus 32. So our numerator is 64. We still have our difference of squares on the denominator. Can't be simplified anymore, so we'll stop there. There's our fraction in lowest terms, 64 over n squared minus 64. Here's one where to find the common denominator we need to factor first, and so we will. The trinomial factors is n plus 4 and n plus 5, and there's a common monomial factor of n in the other denominator. So now we realize they both have a common factor of n plus 5, so we'll need to multiply the first one by n over n, and the second one by n plus 4 over n plus 4. The distributive property applies. We get 2n squared minus 7n, and we get the trinomial n squared plus 10n plus 24 in the second fraction. I brought down my subtraction symbol, and I chose to leave the denominator in factored form for now. And now I have to be careful as I combine those two numerators. I have a 2n squared minus an n squared to make n squared. I have a negative 7n minus 10n to make negative 17n. And the 24 in the trinomial on the right has no like term in the binomial on the left. But because it's a subtraction problem, notice we write minus 24 at the end of the trinomial in the bottom left. Now we look at what we have, and we'd like to factor, but we can't. So we can leave it alone and call that our answer. But some people like to multiply it back, and when we do, we get our denominator is n cubed plus 9n squared plus 20n. Under our numerator, which we've already seen is a prime trinomial, I would accept either one of those two fractions in the bottom line as an accepted answer for the original subtraction problem up at the top. Adding and subtracting algebraic fractions follows the same rules used for adding and subtracting numerical fractions. Use factoring to rewrite all fractions with a common denominator, then add or subtract the numerators. Use factoring again to express the sum or difference in lowest terms.